Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about microservices. So this is something which you would have heard for many years now, and there are multiple architectures that are built based on microservices because it has a lot of benefits. So we are going to talk about what microservices are, what was the need to have microservices, their characteristics, benefits, etc. So let's get started. First of all, what are microservices? As the name suggests, what we are trying to do, it's an architectural style or an approach in which we are developing an application as a suite of small services. Each of these services are running in its own process and they are communicating with each other using lightweight communication. So we are breaking up our application into small pieces which you can term as services or microservices because they are doing one specific thing in the application. So the whole application is collectively a suite of small services. Each of them are having a single objective and they are communicating with each other using very lightweight communication mechanisms. So that is in short microservice. It's an architectural style. Now, why did we even come up with microservices? So earlier, typically when you look at an enterprise application, there would be broadly three layers. One, the client side or the user interface. Second is the database where you are actually storing your data, and then a server side application. So it's a very broad three-level categorization, and typically initially, when the architectures evolved, people were using monoliths. As the name suggests, monolith means a very large, big, fatty application. So there is no breaking of the application into services. Rather, the whole application is built as a single unit, and that is how they were named as monoliths. This was used very widely, but it had its own share of disadvantages. And when we look at the disadvantages in detail, but because of those disadvantages, there was a need to have an architecture which was more agile, evolvable, loosely coupled, and something where you can upgrade, maintain, develop very easily. So that is where microservices came into picture. Now this is a pictorial representation which tells you a distinction between monolith and microservices. So on the left hand side, if you see this is typically a monolith, which means in a monolithic application, all the functionalities are put together into a single process. So one application may have multiple functionalities. For example, if we consider, let's say, Amazon. It's an e-commerce application, right? There is a web application. It has many features, like it gives you a catalog, it helps you to check out or add to your cart and then check out and do a payment for that. It has a recommendation. So where there are various features that e-commerce site has. If it was built as a monolith, all of these features would have been, or functionalities would have been put together as a single process. And how would you scale that? When it is a monolith, a big fat application which has all the functionalities in a single process, how would you scale it? You have to scale it by replicating the monolith on multiple servers. So essentially you are scaling that entire application by putting it on multiple servers to cater to the demand and needs. Right? That is how monoliths worked. But if you look at a microservice, how it is built, it is not everything put together in one particular application or a single process. Basically, this is each element of functionality is a separate service. So payment is a separate service, recommendation is a separate service. Like that, you are dividing the functionality into small different services. And if you have to scale, how would you scale? You would distribute these services across servers based on need. And I can scale these services independent of each other. I don't need to scale the whole application because that is beefy fat. It will require a lot more resources to scale the whole application as a monolith. Here you have an advantage of scaling it up service by service, whichever service needs to scale up. So there is a lot more agility, lot more flexibility in terms of how you want to scale your entire application. So overall, this will give you a picture of the rigidity versus flexibility that microservices have. Now, if we delve into each of the characteristics of microservices, we would be able to better appreciate the disadvantages of monoliths versus advantages that microservices provide. So first, and the basic advantage is you do not have a single application with all the functionalities built in. Each functionality is built as a service. So each service is a component and it is based on the business capability. So what we have done is each of our services are very modular, self-contained, and they serve a specific business purpose. We are not clubbing everything into one. So services are components which are based on business capabilities. The whole mindset is project versus a product mindset, because you are building each service as a product. They would have their own data store. They can have their own language in which you write the microservice. So if you have in an application 3 microservices, all 3 can be written in 3 different languages. So tomorrow, if I want to add, let's say I'm using Angular today for the UI purposes, or I am using some technology which in future I want to replace. So what I can do, I can build new microservices based on new languages. It's not restricted to one language per se. So it's very flexible. The whole concept of microservices is to make it agile, where you develop one microservice independent of the other. You can have different teams working on different microservices, different pipelines to deploy that service. If you are touching one service, you do not have to touch other services or wait for other services to complete and then to deploy. So it's very easy to debug, to develop, deploy as well as maintain. The typical concept here is having smart endpoints and dumb pipes, which means we will have microservices built. They will communicate with each other through some lightweight communication, and as long as you are adhering to the contract the service has specified, you are good. You can change the implementation within and it will not affect any of the services. It has a decentralized governance because you can have different teams working on different microservices. It's a consumer driven contract. Obviously, I am exposing a contract for the service which is based on how that service is going to be consumed. As long as I do not change the contract, I can change the implementation in the background. It has decentralized data management. You do not have a single database to which each and every microservice is talking to. Each microservice can have its own database. So it's kind of self-contained in itself. And it helps in polyglot persistence. So now I can use a different kind of data store for each microservice. Somewhere I can use RDBMS. For one I can use a NoSQL. There is no limitation of using only one, because each service is designed for a specific business capability. Hence they are architected or designed in that way. You can choose different technology. You can choose different data store based on the requirement. These are the advantages of microservices versus if you look at monolith, they had these as disadvantages. You had to stick to one language. Over a period of time, they grew complex and complex. So debugging, maintenance became very hard. If you had to change one part or one thing in that application, you had to deploy the whole application. So that is where microservices came like a fresh breath of air. And they remediated all of the disadvantages that monoliths had. Now, since we looked at so many characteristics and we understood how monolith versus microservices came in and what is the characteristic, let us look at the benefits also. What are the benefits of having microservices? Like we spoke about it, right? Each service is independently deployable, scalable. That's a very big advantage when we are talking about very complex applications. You do not have to wait and deploy, wait for somebody to change the things. If there are multiple places where changes have to be made, you will have to make the changes, deploy the whole application again. There will be a wait cycle. Testing would be harder. But here it is very easy because it is independent, each service. It is deployable, scalable, maintainable. Each service provides a firm module boundary. What is that boundary? That boundary is the consumer contract or consumer based contract that each service has. Each service is built around a business capability which is fulfilling a very definitive objective. Hence, it is very modular. They can be written in different programming languages. They can have different storage technologies. So they are very agile, flexible, scalable, and this makes a life of a developer and a tester and a DevOps engineer very easy. So that is why lot of places we would see microservices being used. Now let us quickly look at the design principles of microservices. Typically the applications that are built using microservices architecture are called as MOA. There are key design principles that we need to keep in mind when we are building any application based on microservices. The first is single concern, which means each service that we are envisioning should have a single business objective. That is very important. That is how you can keep a microservice self-contained. So it will be modular only if we think about a single objective or business purpose for which we are creating that service. Second, it has to be discrete. Discrete means whatever is happening inside the microservice is not really exposed to the consumer. The consumer only looks at the contract of the service. This means that the microservice follows the principle of encapsulation very clearly, so that when you change the implementation or whatever language technology you are using to build that microservice does not affect the consumer. For them, it is always the contract that your microservice is exposing, and they are consuming as per that contract. Third is transportable. Transportable because a microservice is self-contained and built in such a fashion that it can be created, destroyed, replenished based on need. It is extremely easy to scale. Fourth, it carries its own data. Like I said, based on the business capability that your service is adhering to, you can select your data storage, and it comes with its own data storage and data. So it is self-contained and easily transportable, right? Also, it is inherently ephemeral. Now, inherently ephemeral is somewhat linked to transportable, where I was talking about being lightweight, being self-contained. It is easy to bring it up, bring it down. Typically, it's like a distributed system, right? Where you have multiple microservices which are talking to each other. It is ephemeral because you have the flexibility to scale it, to bring it down, to respawn it. Typically, in any architecture which is complex, you would use Kubernetes or the likes to deploy the microservices and scale them. So they are inherently ephemeral, transportable, discrete, having a single concern, and carry their own data. So these are the fundamental design principles which each microservices architecture follows. Now, one last thing that I wanted to touch upon is disadvantages. As we all know, nothing comes with like all benefits. There are disadvantages. So does microservices also has disadvantages. For example, the upfront cost is higher because we are talking about multiple microservices here which will scale independently. You need a very robust infrastructure because this is like a distributed system, and we know that it has its own complexity when we are talking about managing so many different deployable units. So upfront cost is more. The complexity is a bit more than a monolith, and it creates different type of complexity. A monolith had a different disadvantage of being bulky and difficult to debug, maintain, deploy. This gives you all that ease, but it is more complex than a monolith. And it also has to be like the interface control, specifically the contract has to be very well defined, and it is critical because you can't change that. You can change the underlying implementation, you can change the data storage, you can do whatever you want inside the microservice, but the interface control is very critical. And when you talk about applications which are very complex, and if you have too many microservices, it becomes a very big nightmare to manage and maintain them. So it has to be a very conscious choice of should we use microservices or not. It's not a silver bullet for everything. So I hope this gives you a very good idea about what microservices are, how it differentiates from monoliths, the design principles, advantages and disadvantages. So keep liking, sharing and subscribing to the channel for more interesting videos. Thank you so much.